Hello students, next thing that we're going to go through, this is 12.1, is we're going to go through sequence. So sequence is just a list of numbers. So the first thing we're going to look at is each number in the list is called a term. We're going to look at writing equations. So look at a pattern of numbers and how could we write an equation for that list of numbers. So first thing we're going to do is distinguish between what type of list do we have. There's two types of lists that we'll look at, arithmetic and geometric. And we'll go through that. An arithmetic sequence is when you add to get to the next term or you subtract. So you start off with 5, 10, 15, 20, 25. You're adding 5 each time. Or if you had 30, 28, 26, 24, 22, you're subtracting 2 each time. When we talk about this term number, that's the spot it's in. There's the first term, where it starts out with, then it goes on. We're going to write an explicit rule. An explicit rule is a rule based upon its position it's in. And then a recursive rule is always about what's in front of it. So to write a recursive rule, I'd say we're adding 5 to the term in front of it. Okay, here's the big thing. Write this down. Recursive formula is this. F of n equals f of n minus 1 plus d. D is the common difference, what we're adding each time. We're just going to look at arithmetic sequences today. Arithmetic, like we're adding to get to the next term. F of n minus 1 always means the term before it. So if I want to find the 10th term, I need to know the 9th term. I need to know the term in front of it, and then I would add to it. The explicit formula is based upon the position. So if I want to find the 10th term, then I plug in 10 for n. So this would be n minus 1. So again, here's our next one. F of n equals a, okay, our first term, plus d, my common difference, times n minus 1, the position it's in. So again, if I want to find the 10th spot, I would go 10 minus 1. Okay, f of n minus 1. So you got to distinguish between f of n minus 1 and n minus 1. F of n minus 1 means the term before it. N minus 1 is just the position it's in. So you can spot a recursive formula because of f of n minus 1. An explicit formula will just have an n in there. There won't be a f of n minus 1. So we'll be able to go through and distinguish. What we want to do is we want to write a recursive formula and an explicit formula. So that's what we're going to be going through and writing. There's recursive and explicit for the problems that we have. So first thing we'll come to is we look at it. So again, this is the position. We're starting at the 0 term. So 0, so our first term is 2. Or I should say our first term is 5, 2, and 8, 3, and 11. So this is the position it's in. This is the value. So you 2, 5, 8, 11, 14, 17. All right, so as we look at this, what is our pattern? What are we doing for each one? Well, if you look at it, we're adding 3 each time. Add 3, plus 3, plus 3. So to write a recursive formula, so our recursive one would be f of n, okay, f of n equals f of n minus 1 plus my common difference, plus 3. That's it. You're done. Our explicit formula says, okay, explicit, it says, if you remember, it says f of n equals a plus d times n minus 1. So I need to know my first term. What's the first term? Well, I go, okay, this is the one in the first term. My first term is 5. So I'd say, okay, f of n equals my first term plus my common difference, which we said was 3, times n minus 1. Now again, what does this do? Is if it says, I want to find the 20th term. Well, with the recursive formula, if I want to find the 20th term, I need to know the 18th term. Or excuse me, if I want the 20th term, I need to know the 19th term, which means I have to find the 18th term. And so the recursive formula, if I want to find the term way down here, I can just plug it in. So if I want to find the 20th term, I would go 5 plus 3 times 20 minus 1. So 5 plus 3 20 minus 1 is 19. So that would be 57. 3 times 19 is 57. And then I add 5. 5 plus 57 would be 62. So I know that the 20th term has a value of 62 for it. Let's go to the next one. So if I want to find, look at my pattern. So this one, it starts off at the first term, second term, third term, and I look at my pattern. Now here we're subtracting 4, subtracting 4, subtracting 4, subtracting 4, subtracting 4. So my recursive formula just says f of n equals f of n minus 1 minus 4. That's it. The explicit formula says, okay, f of n equals my first term. What's in the first term? That'd be 29. Plus, okay, negative 4 times n minus 1. And there you have your two recursive and explicit formulas. Look at the last pattern. There we go. We'll look at our last two on here. So they start out with a 0 term, so the term that we're looking at is the first term. Negative 7 to 2, if I'm not sure. Negative 2 to 3, not sure. 3 to 8, oh, I know that, that's adding 5. Oh, that's adding 5. Adding 5, hey, my common difference is 5. If I added 5 to negative 7, that's what I get. So again, the explicit formula, f of n equals f of n minus 1 plus 5, pretty simple. Recursive formula, again, start off with f of n equals my first term. What's in the first term? Negative 2. Plus my common difference, 5 times n minus 1. And there it is. The last one, if I go from 11 to 5, how do I do that? I subtract 6. Well, does it work every time? Yep, subtract 6, subtract 6. There you go. So I'm subtracting 6. We know my first term is 11, so I go f of n. For my recursive formula equals f of n minus 1, subtract 6. For my explicit formula, f of n equals my first term. What's in the position of the first term? 11 plus, okay, negative 6 times n minus 1. And there we have it. So that's how we go through writing the explicit and recursive formula based upon the sequence that's given to us. So now when we go and look at it, we could look at a story problem. There we go. There we go. So there are 19 seats in the row nearest to the stage of the theater. Each row after the first row has 2 more seats than the row before it. So if I had a stage up here, and then I had this first row, it's saying that has 19 seats in it. The first one has, there are 19 seats in the row nearest the stage of a theater. Each row after the first one has 2 more. So it would be 21, then 23, and so on. Okay? What we want to do is we want to write the explicit formula and recursive formula, and then we're going to find how many are in the 13th row. So again, I would go ahead and say, okay, the recursive formula is just f of n equals f of n minus 1, and we're adding 2 each time. Now, that's great, but if I want to use the recursive formula and I want to know how many are in the 13th row, then I need to know how many are in the 12th row, which means how many are in the 11th row, and 10th row, and 9th row. Basically, if I use the recursive formula, I have to write it all out. So I'm going to use the explicit formula. The explicit formula is the one that has the most power. My first row has 19 in it, plus I'm adding 2 every time, times n minus 1. So I want to know how many seats are there in the 13th row. So I go 19 plus 2, and then 13 minus 1. So 19 plus 2 times 13 minus 1 is 12. 12 times 2 is 24. And then 24 plus 19 would give me 40 3. So we know there are 43 seats in the 13th row as we go through. So just wanted to show you this one. Okay. A student with a part-time job borrowed money from her parents to purchase it. The graph shows the amount the student owes her parents as she makes equal payments. And how many weeks after the purchasing the bicycle will the loan be paid off? So we know she borrowed $800. Okay. Then, and one thing I want to, let me get you to it. If I look at, okay, technically we're starting at 0, so I'm going to start here. This is my first, right there. That's week 1 is the one that we want to look at. So right here, okay, this is 700 right here. So what's in between 800 and 700 would be, this is 750. So then this is 700, this is 650, this is 600, this is 550. So we can see our pattern. What's our pattern doing? Is she is paying her parents $50 every week. So if you think about it, her first term is 750. So if I wrote an explicit formula, say f of n equals 750, okay, she's going down, that payment's going down, so you go plus negative 50 times n minus 1. Now, what we want to know is, after how many weeks will this be 0? Will she have no money like to pay off? Okay, so when we do that, we're going to actually plug in 0 for here, equals 750. Now I'm just going to put minus 50 times n minus 1. So we can go ahead and distribute here. So we get 750 minus 50n plus 50. 750 plus 50 is 800 minus 50n. Then you'd subtract 800 equals negative 50n. Divide by 50. And you would get 16 equals n. So it would take her 16 weeks to pay it off. You guys, you could also think about it. If the loan's $800 and she's paying $50 off every week, you could also do it that way as well. But that's a way for us to write, look at a formula, look at a pattern. From that pattern, write an explicit formula, and then be able to solve either for the number of weeks or the value that that term would be as we go forward. So that's on arithmetic sequences.